In this lesson, we're going to be simplifying complex rational expressions. When you look at the first one, or either of them on this first page here in your notes, you can see that it looks like it's a really kind of weird fraction, right? They're kind of complex. We have a fraction divided by another fraction. So we're going to be really organized in how we do our work here and hopefully be able to divide them up and split them out so it's easier for us to see what we're doing. So before I can actually divide these fractions, I have to simplify the numerator fully and simplify the denominator fully so that I can have a real fraction to divide by. So first we'll do the numerator, and I want you to write this in your notes just like this so it's easier for you to see how you did your work. If I'm taking f over 1 minus 2 over e, I need to subtract those numbers. I have to find a common denominator. So hopefully you would see that the common denominator between 1 and e is e. So I ask myself what changed from this denominator to this one, and that would be timesing by e. So I multiply my numerator by e and I get ef. What changed from this denominator to this one? Nothing. So nothing changes in my numerator. So my new numerator is ef minus 2 over e. So there's your new numerator. So in this problem, I can rewrite this as ef minus 2 over e. And then it's going to be divided by, and we need to find a new denominator. So I'm going to come over here and do my denominator. So this is done for numerator. My denominator is f squared over 1 minus 1 over e squared. So my common denominator between those two, hopefully you see, would be e squared and e squared, because the other one's a 1, which makes it a lot easier. So what changed from this denominator to this one? An e squared. So I need to multiply that one by e squared. So I have e squared f squared. What changed from this denominator to this one? Nothing, so nothing changes. So when I combine those, my new denominator would be e squared f squared minus 1 over e squared. So when I come up here, I'm going to write e squared f squared minus 1 over e squared. Now, if you're getting confused already, that's normal because this is pretty confusing. So there's all my work for the new numerator and denominator. So now I have an actual problem I can figure out. When I do this, this problem is the same as writing ef minus 2 over e divided by e squared f squared minus 1 over e squared. So now I do this like I've done all my other division problems. I'm going to multiply by the reciprocal. So I would have ef minus 2 over e times e squared over e squared f squared minus 1. In order for me to cancel anything, I need to factor these fully if that's possible. So when I take a look, ef minus 2 does not have a greatest common factor. E is fine, e squared is fine. E squared f squared minus 1. This is the one that's going to be kind of confusing for us to do. But what we can actually do with this, and it'll come up later that this works out for us, this could be factored into ef plus 1, ef minus 1. Now, I don't believe that on your accelerated math, when you use this, that's ever going to come up. I just wanted to show you that that is a possibility, and I didn't want you to be confused by that, maybe if you learn about it later or something. So the way Excel math doesn't make it that hard. They actually leave it just like this. Oops, let me just rewrite that one too. So it's going to stay the e squared f squared minus 1. So now when I reduce this, the only thing I think I can reduce is these e's. So I would have e times ef minus 2 over e squared f squared minus 1. Now, this is a correct answer. I just know that on Excel math they normally distribute this e in the answer, I believe. So we could write e squared f minus 2e over e squared f squared minus 1. Both answers are perfectly correct. I think the second one is Excel math, but I actually can't remember right now. So whichever way the Excel math answers are giving it, make sure you you'll pick that one. But on a test that I give you when you do this by hand and you don't have solutions to pick from, either answer would be perfect. So that one looks pretty complicated, but when we do it step by step and break it down, it really wasn't that bad, I don't think. So now let's try number 2. Same idea. We're going to have to reduce our numerator first. So my numerator is x over 1 minus 1 over x squared. So my common denominator, hopefully you would see, would be x squared. It's really nice when it's a 1, huh? What changed from there to there? So this becomes x cubed, and then this stays a 1. So my new numerator is x cubed minus 1 over x squared. There's my numerator. Now for my denominator, I would have x over 1 minus 1 over x cubed. Common denominator would be x to the 4th. Oh, just kidding. How about x cubed? We don't have an x to the 4th. I'm jumping ahead a step. Common denominator is x cubed. So what changed from here to here would be x cubed. So now my numerator here is x to the 4th, and then nothing changed there. So my new denominator is x to the 4th minus 1 over x cubed. So my new problem is really this divided by that. If I want to write that out, I would say it's x cubed minus 1 over x squared divided by x to the 4th minus 1 over x cubed. Again, when I'm dividing fractions, I really multiply by the reciprocal. So there's what I get. Now, this is going to be your favorite one, I can tell already, because when I factor, take a look right here, that looks like a difference of cubes problem, doesn't it? So remember your formula. This is a difference one, so the formula is a minus b times a squared plus ab plus b squared. So my a is the cubed root of the first term, which in this case is x. My b is the cubed root of the second term, which in this case is 1. So when I factor this, I would have x minus 1 times x squared plus 1x plus 1 squared, which is 1. Hopefully that looks okay. My x squared and my x cubed can't be factored, but x to the 4th minus 1 looks like a difference of two squares, doesn't it? So it'd be x squared plus 1, x squared minus 1. Now, just to really throw you for a loop, I happen to also have more factoring this problem, because that x squared minus 1 is another difference of two squares. So I have to actually say this would be x plus 1, x minus 1. Now you will find that the ones you do in Excel math are patterned very similar to these, so you won't be doing a bunch of different ones like this. They'll all kind of match up a little bit, and you'll get used to how you would reduce these, and it'll help you when you're going through your work with this. So when I cross cancel, I can cross cancel these x minus 1s, and then I can cross cancel the x's and x squareds. So I would have x times x squared plus 1x plus 1 over x squared plus 1 times x plus 1. And that is actually my answer. So again, these can be really complicated looking. Like if you show someone this work, they'll think you're a genius. But if you go step by step, they're not too bad. So now we're going to try the last two. This one is the biggest pain in the butt, I think, because it has lots of different steps. So the first thing we're going to do is simplify this numerator right here, because I can't divide right here until I have that numerator simplified. So that's going to be 3 over 1 plus 3 over 3 plus g. Common denominator, hopefully you see, is 3 plus g. So this 3 would have to be times by 3 plus g, which makes that, I'm just going to go ahead and distribute right away if that's okay. I have 9 plus 3g, and then nothing changes in that denominator, so I'm just going to keep that a 3. So when I combine like terms, I have 3g plus 12 over 3 plus g. So that's this new denominator here, 3g plus 12 over 3 plus g. So now, if I use my g in the top, I have g over 1 divided by what I just found. So remember, when we divide, we multiply by the reciprocal. So I'm going to flip those. Even if I write this as 3 times g plus 4, nothing's going to cancel here. So I'm just going to go ahead and distribute that g and get 3g plus g squared over 3g plus 12. Now, what I just found is all of this right here is equivalent to all of this right here. So I simplified that fraction as far as I could go, which is what all our other problems were. I mean, we just took care of that part. The new part is I have a 3 plus. So I really have 3 over 1 plus what I just circled in red. So plus 3g plus g squared over 3g plus 12. So to find my common denominator, I would say that it's 3g plus 12, right? Because it's times a 1. So what changed from this denominator to this one is the 3g plus 12. So we would have to actually distribute here and get 9g plus 36. And then nothing changed here, so I'm going to leave that 3g plus g squared. So since I have a common denominator now, I can go ahead and add these like terms in the numerator. I would have a g squared plus 12g plus 36 over 3g plus 12. So now I'm going to try to factor my top and bottom and see if anything cancels. In my numerator, I would have g and g. Factors of 36 and add together make 12 are 6 and 6. I'm going to take a 3 out of my denominator. And I notice that absolutely nothing cancels. So to write this in simplified form, I would say g plus 6 quantity squared over 3 times g plus 4. And that's my final answer. Since nothing canceled, this could have been my final answer also. So Excel Math could answer in either one of these, and you could choose either way to answer on your test. The last one is a little bit more like our first one, so I would like you guys to stop the video and just start it and try to simplify the numerator, simplify the denominator, and then put them all together. So in this one, when I do my numerator, I have c over 1 minus 5 over b. Common denominator would be b. So this would be bc minus 5. So my new numerator is bc minus 5 over b. And then that's going to be divided by, that's my numerator, right? So now I'll do my denominator. C squared over 1 minus 1 over b squared. Common denominator would be b squared. This would be times by b squared. So it would be b squared c squared minus 1. So this is b squared c squared minus 1 over b squared. So when I write this out, I would have bc minus 5 over b divided by b squared c squared minus 1 over b squared. Again, when I'm dividing, I'm really multiplying by the reciprocal. And then when I go to cancel, I got this and this. So my answer actually, if you remember, because we don't have to factor that at all, is b times bc minus 5 over b squared c squared minus 1. Or, if you distribute that b, it would look like this. Now, these are very confusing, and so it's going to take you a while to catch the hang of it, but you just have to kind of dive in and try some on your own. And make sure when you make a mistake, don't erase your work. If I'm going to help you with it, I want to look through your work, because you'll probably do tons of stuff right and just make one little mistake, and then I can find it and you won't have to do the whole problem again if you get lost. If you have any questions, make sure you let me know tomorrow.